Good morning, everyone. It gives me great pleasure to welcome all of you to the webinar on unlocking the potential of IoT data. I would like to give a brief introduction about myself first. I am Ramin Irani and I work as a principal architect on big data and IoT at Zorient. I've spent a good part of my 2 decades in the software industry developing a variety of applications for enterprises, and I've been lucky to see the evolution of sensor technologies from barcode RFID to the low cost sensors that are available today. So when we first started developing sensor apps years back, the challenge was more around, making the app devices work and writing drivers for them. But then it evolved into centrally collecting this data for easier analysis with the right tools, and also communication standards like HTTP and internet. They played a key role in facilitating this whole collecting and analyzing data. So where we stand today is the emergence of big data coupled with efficient sensor devices that would give great advantage to any organization that implements these technologies today. But what we need to also understand is how we're going to architect this IoT platform so that you can utilize not just sensor data, but combine it with big data and analytics to play a role in making success of your application. So that's what we're going to see in this webinar today. Let's get started on that. So in the agenda, what we have is we'll be doing an introduction to the Internet of Things and the factors to consider in any IoT ecosystem, and how do we effectively implement it in order to make it a success. And along the way, what we'll be also discussing is some of the key factors around big data and security that we believe is going to play an important role in order to make sure that your IoT applications are a success. Then we'll cover a few real world use cases. These are projects that we have worked on, and you will see how we've used IoT to get maximum advantage out of the data that was collected. So we'll get going now with the webinar. And first, we're going to look at the market opportunity for IoT. So when we look at this, there's a lot of market research that has gone into, projecting the number of smart devices as well as, the connected devices of various kinds. And you can see the sheer numbers that are out there along with the business opportunity that's there for enterprises. But the key thing that's really driven this whole, trend towards sensor and IoTs is that the triggers which you see here on the screen. So one of them is the low energy sensors. These sensor devices now are pretty much low cost. They're easy to get connected with, and you can pretty much hook them up quickly to the emerging protocols that are there. And coupled with the internet infrastructure and the cloud that's already there, it's become straightforward now to collect data, push it into a server-side system where you can analyze it. And the key thing really now is that organizations are really looking at tapping this sensor data and mining into it in order to achieve maximum advantage out of that. So these are the key triggers that are really driving, the whole shift towards getting these devices in place, collecting data and analyzing it. The screen which you see here now, IoT applications. So first I'd like to discuss the different categories of applications. And pretty much now it's not just in the consumer side of things, but even on the commercial and industrial, where between organization to organization to the applications are there in place. And apart from categories, you could briefly break your IoT applications into two types roughly, and which are shown here. One is around analysis and control. By analysis type of IoT application, these are applications where the sensor is collecting data and is pushing onto the server side for analysis. So it's really just one-way traffic that you are, pushing from your devices onto server side, and you're visualizing and analyzing it. The control type of IoT applications, it's been there for a while via control systems. But here what happens is that the data that you're pushing from your devices, it goes to the server side for analysis, but some of it even comes back to the devices where you want to maybe trigger an action on the device, or you even want to manipulate a parameter or to tweak it in order to make it function as per your calibrated or any threshold value. So analysis and control are two types of typical IoT applications that you could look at while implementing it in your organization. Now, the next thing we are going to look at is a series of criteria. So if you're evaluating any platform for your use from an IoT perspective, what are the different areas that you should be looking at in order to evaluate a platform correctly? What would be the different factors that will come into play? So first up are the devices. These are the devices or the low cost sensor devices, the microcontrollers of the world that you would be using in order to capture the sensor data. Now, once this data has been captured, the next thing you want to do is that how do you move this data from your devices over to any middleware or server side layer that you've got. So there you need to think about some of the communication protocols. Now, the communication protocols, we have a slide later where we'll cover it, but this could be HTTP or even among the emerging communication protocols, which are well suited now to IoT devices like MQTT or HTTP2 also. So one side are the devices, then you're trying to now move the data or the sensor data from the devices onto your middleware via communication protocols. And there, as you're moving it from the devices, the key thing to keep in mind is privacy and security of data. This is going to play a very effective role because you obviously want your data to be secure. It's going along secure channels from your devices onto your middleware. So the best practices for security do apply over here. Common message formats. While there is no standard or agreed upon format for different sensor kind of data that is industry wide and acceptable, what we suggest over here to consider is come up with common message formats for the sensor data that you're moving from your devices to server side. What this helps you to do is to normalize the data that's coming in from a variety of devices. This will help shield you in future in case you want to swap out devices from one manufacturer to another. So it at least helps you to normalize or canonicalize the message formats that you're going to move from your devices onto your middleware for analysis. Now, so you looked at devices, then you're moving the data over to, the via some communication protocols in a secured way. You may translate it to a particular message format that's standard for your backend systems. But then comes a very critical part, which we believe is key to the success of any IoT application, which is around ingestion, aggregation, and analytics. So by the ingestion layer, what we mean is that this data that's coming in from the devices, now it could be from a few devices, or as you scale up, it could be even thousands of devices sending a wide variety of data with a pretty large volume or the rate at which the data is coming in. So what you need is a good ingestion layer that is able to both take the data in batch format or even real-time format, and then you need to be able to query it so that in case there are any alerts that you wish to raise at the edge, or even filter out the data, or even aggregate it into any other common formats, you could do it at this layer. So once you have this ingestion layer that's sort of tackling the data that's coming in from various devices, you may then want to sort of store it onto your backend data storage architectures and applications which you've got. Therein you may even perform your data analytics, and or the integration layer which you see, that's for taking the data and then moving it into your backend systems. Now, I'd like to just speak about client libraries. The client libraries that we are talking about here are really frameworks which could be in one or more popular programming languages. And the key here is that these libraries, if present for the particular IoT platform, would help you really jumpstart your application. So if your programming team is comfortable with a particular programming language, the existence of client libraries in an IoT platform would really help to integrate it much more quickly. Now, so if you look at this whole layered approach where we're going from devices to a communication protocol and then securely moving it into an ingestion aggregation layer and eventually into your backend systems for integration and analytics. And the key thing that comes up here are the points which you see here, which is around insertion, aggregation, and analytics. And we'd like to repeat that creating this layer in your IoT platform is going to be the key to not just handling large amounts of data from various sensors, but an ability to filter out and to aggregate it in the way that you want and eventually pass it on to your analytic systems which you have for analysis. So according to us, from our experience of developing applications, a great insertion aggregation analytics layer is going to be key to the success. Now here we saw a general layering of the different areas or criterias that you need to look for while selecting an IoT platform. So what we have now on this slide is a sort of a layered architecture over here. So here what we are talking about is sort of just giving you another high level view that on the left side, leftmost side, that is, you have your devices. And now these devices could be any of the sensors, microcontrollers, even either handheld computers or even wearables that are sort of collecting sensor data, aggregating it maybe at even the device level, and then they need a mechanism via the network to transfer this data onto the middleware. Now, the middleware here at a high level could comprise of asynchronous architectures that could allow for ingestion of data in a batch mode, or you could even have a real-time, ingestion layer that's capable of accepting a data at a high rate. Now, over here, you could do your queries. You could filter out data that you do not want to really ingest into your backend applications. You could even raise any alerts that you want to at this point in time. And eventually, this whole data would then move into via an integration layer into your applications at the backend. So there, it could be your analytical platform. It could be then any other visualization software that you may have to analyze the data that's coming in. So this layered architecture sort of shows you the different pieces that would be there in any high level IoT application. So it's got devices, you've got your middleware, and then eventually your backend systems where you will perform the bulk of the analytics. And even there could be a feedback loop. We saw the two types of apps. So you could eventually even have a feedback loop that goes back and then triggers some action onto your devices. So now what we'll see is, like based on our experiences, there are two key things that we believe would be critical to success of an IoT platform or an implementation. And the first one that I'd like to touch upon is big data. Now, when initially you start your IoT applications, it could begin with a proof of concept. You could have a few devices initially, and what typically happens is that as you scale up, these traditional architectures that are able to handle a small amount of sensor data and devices may not be able to tackle that. So the three V's that we know about big data, that's variety, the different types of data that's coming in, the volume of data, and the velocity, the rate at which it could come in. These are key factors that could really break down, traditional application architecture. So what we have seen is that in order for you to make sure that you're future proof when it comes to a large amount of sensors and devices is to look at big data architectures on your server side. So this could help you to eventually scale to thousands of devices, potentially, do a real-time ingestion of data when the velocity is high, and you still need to, sort of find out different patterns in your data, even real-time alerts. So we suggest that when it comes to complex data processing pipelines, which you will have in the future, it's important to invest in a big data architecture. So that's one of the key considerations which you should consider while looking at a long-term IoT solution that scales as your number of sensors and devices increases. The next thing which is critical is security. And I'd like to touch upon the points over here. So the first couple of points are the transport level security and data encryption. And these are the, any key security best practices that you would find at any point in time when two, sort of layers are communicating to each other across a transport medium. So they definitely come into play. The next thing is about device ports. Now, each of these devices or the sensors which are there in the devices, you may want to ensure that only the required ports are open for communication. And it's not just about the required ports, but also the whether the incoming traffic is allowed on the port or an outgoing traffic or both incoming and outcoming. So you need to make sure that these security settings are correctly put on the devices. Protocols, right? Often it is said that maybe HTTP protocol that we have in place today is a fair enough protocol to go for. But what happens is that we need to keep in mind that most of these devices are pretty low powered devices. They also have low processing power, and often they are deployed in environments where the network is not very reliable. So as a result of that, you need to look at protocols that have been designed from the ground up for various things like retry mechanisms where the data packets are not very the protocol is not too heavy on these devices from a processing perspective. So towards that, there are protocols that are very well suited to that kind of communication. So MQTT protocol is one. There's WebSockets. There's also the emerging HTTP 2.0 protocol. So what we would highly recommend is that when you're looking at an IoT implementation, do consider these alternative protocols also. That might be very critical when it comes to devices that are working in unreliable network environments. They have low network bandwidth sort of scenarios, and the communication data format needs to be pretty small and not very heavy in terms of the payload. And device monitoring upgrades. Uh, this is a key point because once you deploy these sensors out there, what happens is that over time you need to monitor them to make sure that they're working or not. You need to check on the health of these devices. You may also need to perform some upgrades on these devices. So you need to ensure that the channel through which, from a server side, if you're pushing any upgrades or monitoring any of these devices, that particular transport channel is also secure. Right. So to summarize on this slide, big data and security over some of the repeated implementations that we've done are two key areas if and which, if addressed correctly, would go a long way towards making your IoT implementation a success. Finally, we'd like to also take a look at two use cases that we have. So the first use case is for a transport company that wanted to track and monitor its shipments while in transit. So the scenario here is that what you see is a representational diagram of one tracking device. So this tracking device was put on a container on a ship that is moving, along the ocean. So you can imagine now if you just multiply this, that there were multiple ships, out there moving. Each ship had multiple containers, and these containers had the tracking devices. Now, what the client wanted to get from this traditional track and trace application was to know if, of course, to locate where the shipments are, to also look at the different times that it's able to go through the various hops. It wanted to know if the containers have been offloaded and loaded correctly. It wanted to even know if the containers have gone missing somewhere or they've gone on a wrong route. So you can imagine now that all these parameters were being captured by these tracking devices. And since they could be working in areas where network is not there, these records were aggregated, and then via a single app, they were sent over to the application on the server side whenever the network was in, it was the connectivity was established. Then on the server side, obviously there were, it fed into the data storage analytics application where you could visualize then how this whole thing was, tracked, where they could locate where their ships are, the containers are, and everything. So it really helped to, improve the on-time performance and even to tell the customer where their shipments were. The second use case that we have is around renewable energy. And this was a company that was producing various power storage devices, so inverters, generators, charge controllers. And here the thing was that all the sensor data that was being collected by the devices and pushed into the backend, it helped the client do various things. So one is not just collecting the data and understanding, how the devices are being used, but it also helped in any predictive maintenance. So if certain devices were not functioning properly, they could react to it much quickly. It helped in monitoring it from a remote location. Also understanding if there were any parameters that could be pushed back onto the devices to control it or not. So it gave a great insight into the way the consumers were not just using their devices, but even giving the feedback back at how they could be more power efficient in order to save either on cost as well as on energy consumption. Finally, I'd like to just talk about the Zorian IoT Center of Excellence. So here, what we have is, a center that's dedicated to IoT, where we, look at, we have implemented multiple implementations on IoT domain, but we've also combined this practice with our big data and analytics practice that helps us, really gain more insights in terms of the data that's coming out. And what you see on the right side is the Zorian IoT Application Accelerator. And over our experience of developing multiple applications, what we've done is that we've identified several pieces of applications or functionality that we found common across various apps. For example, data storage or device management or even client libraries. So this helps us really jumpstart various applications that we want to do on the IoT side of things. It gives us well-tested components and cuts down our development by a large extent. So what I'll do now is I'll take in a few questions, but to summarize, we've looked at the IoT opportunity, looked at IoT platform criteria, given you a few areas like big data and security to consider, and then we covered a couple of use cases. So I'll take a look at some of the questions that have been coming in, and I'll answer those. Okay, the first question is that is HTTP protocol sufficient for device to server communication, or are there other protocols that are more apt for IoT? Yeah, that's a great question. So I'll just go back to one of the slides we have here on security that talks about protocols. And if you look over here, we've stressed that while HTTP could be a good protocol, for communication, from your devices to your server side. The fact that these sensor devices have to work in areas where network connectivity may not be that good, or the fact that they also are low powered, low processing capability that they have, there are other emerging protocols like MQTT, WebSockets, HTTP2 that may be more apt for communication. So we definitely suggest that look at these other alternative protocols that may be more well suited for the kind of use case and operating conditions that you may have for your project. Hope that answers that question. I'll move on to the next one. Is there any standard format for sensor data captured by various devices? Yeah, so at this point in time, the answer is that there is no standard data format for capturing of any sensor data. So while there are various bodies at work that are trying to come up with a standard, it's not an acceptable standard yet, or a widely adopted standard by most organizations. So while there may be different data formats, what we suggest, as we had highlighted here in the IoT platform criteria, is a common message format. And that's what we believe is going to be a key to your success, in order for you allow you to switch between even devices and different data formats that the devices may return to you. So the normalization on common message formats is going to be a key factor, so that your ingestion, aggregation, and the analytics layer can at least be working off a common data model. So coming up with a common data model is important. Yes. Okay. The next question is, what are the design considerations for an IoT API? Okay, this is a slightly wide-ranging question, but I would like to touch upon certain factors of an IoT API. So when you're talking about an IoT API, I assume that you're talking about the server-side layer, and this is the API probably at the ingestion layer, which your devices would be communicating and sending data to. So just like any other endpoint API, obviously one of the factors for, I mean, the design considerations could be security. So you need to secure that endpoint and make sure that the transport level as well as data encryption is there in place. From an ingestion API point of view, you need to understand that whether it's going to be a coarse-grained API or a fine-grained API, because these devices may not always be connected, and it may not be very optimum to make multiple calls for them. You might want to look at maybe even a batch ingestion of data, and not just at every fine level where every transaction needs to be an API call. So you need to design your API also from that perspective. um, when it comes to message formats, you'll have to make a decision there as to what are the message formats that your devices would be sending to you. So they would need to obviously confirm to that. Any kind of client libraries in multiple programming languages, if you could make that available, that would be a great thing, because that will really help jumpstart others to develop applications for which can work against your API, rather than working at the protocol level itself. And obviously, underneath that client library, you'll have to make the decision as to what are the communication protocols this API can be used to talk to. So whether it's going to be just HTTP, or is it going to be anything else, you'll need to think of that. And then finally, so when you look at the whole API sort of thing, the best practices do come up, but then from a communication, security, message format, and client libraries, this would be key. Okay, I'd like to take another question also. The question is, what are the big data technologies that could be used here? Okay. So, if we look at the big data technologies, what we're talking about here is that the three V's play a big role here: the variety, volume, and velocity. And there are big data architectures already in place, or frameworks already in place that do a good job of this. So the I mean, Apache Hadoop based framework is a key candidate that you could use from a big data implementation point of view. In our some of our recent applications, we've also made use of Apache Spark that allows you to look at both batch as well as real-time ingestion of data. So yeah, to answer that question, yeah, Hadoop-based architectures are key here for your big data implementation. I'll take another question. What programming languages are used in writing the IoT applications? And do these platforms support multiple languages? Okay. So for programming languages, let me go back to yeah, this particular high-level architecture screen. Now, when the programming languages, they play a role depending upon which layer you are at. So when you're talking about devices, on the device level, typically, because the application code needs to be small in footprint and extremely efficient, our experience has shown that when it comes to writing drivers, languages like C play a big role when it comes to that. However, as you move up the stack and go towards middleware and applications, there is no restriction in terms of which language is well suited or not. There are frameworks, and depending upon the applications, you could use any particular language that you want. So on the server side, you could use Java, you could use any of the Python or PHP or anything that basically your application is supporting. There is no restriction in terms of a programming language there. Okay, I think we've come to the time duration for our webinar, and while there would be more questions, and we would respond to each one of them, what we'd like to do over here is to mention to you that you could contact us anytime on this email ID which you see over here regarding either this webinar topic or anything around your IoT implementation or application that you may want to develop. So once again, I hope this webinar was useful to you. I have had a great time presenting it. Thank you so much for attending.